Hello everyone. In today's lesson we're going to talk about Galileo and the property of inertia. So let's start by considering the following scenario. Let's say we have a box that sits on a horizontal surface. We push on the box with a force F and the box starts to move to the right. So what would you say would happen if we stopped pushing on the box? Will the box continue to move? Will the box come to a complete stop? What will be the outcome? If we remove this applied force, what will happen to the box? And this is a question that Galileo considered in a slightly different form. Most people are going to say that if you stop pushing on that box, the box will stop moving. Galileo's experiment shows that this is not necessarily the case. So let's sort of outline Galileo's experiment. Pretty simple. We start with an incline, double incline actually, of about the same degree of steepness. We have a ball on that incline, and we're going to release the ball so it rolls down the incline. And what Galileo finds is that for a smooth incline, let's say that this incline is made out of a smooth material, the ball will roll down the incline and then up the opposite side to the same height, h. Now in reality, there's going to be, even for a smooth surface, a little bit of frictional resistance that will dissipate some of the mechanical energy of the ball, and it will end up rolling to a slightly lower height on the right side. But if we ignore frictional effects, the ball will end up at the same height on the right side as it started on the left side. So this is where Galileo gets a little creative with this thought process. We start with the same incline, but we make our second incline less steep. So now, if we release the ball, what we find is that the ball, again, travels down the first incline and up the second, but it travels a greater distance, ultimately ending at the same height that it started, just as we saw in the first example. So final position on the right here, height h, is the same as the initial position on the left. But because the second incline is not quite as steep, the ball has to roll through a greater distance to get to that same height. So if we extend this situation then, such that the second incline is no longer an incline, but just a horizontal surface, and we release the ball, the question then is, what is the final position of the ball on the opposite side? And Galileo says, well, there won't be one. It will keep going on forever in a straight line with constant speed. And this idea that the ball is rolling and it will continue rolling until something comes along to stop it, is what we refer to in physics as the property of inertia. So again, the idea here is that this surface is frictionless. Once the ball rolls down the incline, rolling horizontally, as we've seen in the previous examples, the ball will continue to roll until it reaches the same height as its initial height on the left. But that won't happen in this third case. So the ball will continue to roll forever at constant speed in a straight line, assuming there is no force to stop it. Now, of course, if there's friction on this horizontal surface, that frictional force will oppose the motion of the ball and will cause it to slow down, decelerate until it comes to a complete stop. But in the absence of friction, that ball will continue rolling on and on forever. And this concept is referred to as inertia, the principle of matter to continue to do what it is already doing. Stated another way, we say that inertia is resistance to changes in the state of motion of an object. So this rolling object has opposition to changes in its state of rolling, its state of motion. It wants to keep doing what it's already doing. And if we push on it to try and stop it, it's going to push back on us. It's going to resist that change in its state of motion. And this principle, again, is what we refer to as inertia.